covered. The lowest layer of the solar atmosphere, closest to the surface, is called the chromosphere, or literally the sphere of colour. During an eclipse, this can sometimes be a really interesting region. This is where we might see prominences off the edge of the sun, as you can see here. The chromosphere has significantly fewer atoms in it, which means that during normal conditions, it's almost invisible to us because it's dominated by the photosphere, which is far more dense. However, once we cover up the photosphere during a solar eclipse, the chromosphere can now really shine bright, and we can see a lot more detail than we ever could while the photosphere was on show. One thing that's very unusual and that we still don't have a good explanation for is the fact that once we leave the photosphere and move out towards space, the temperature that we see on the sun is actually increasing. So it's getting hotter the further away from the sun that we get. And we start to notice this in the chromosphere first of all. If you've had the benefit of looking at the sun through a H-alpha telescope, or during the solar eclipse once the photosphere is covered, you'll notice the chromosphere by its red material that's protruding from the edge of the sun. This sphere of colour can be very beautiful and really interesting during a solar eclipse. Once we leave the chromosphere, we again reach another boundary region called the transition region. Compared to the thickness of the other layers of the sun, the transition region is really, really thin. It's only 100 kilometers or so thick. But what's very strange is that in this really narrow region, the temperature and the density of the sun changes dramatically. So we go from about 10,000 degrees on the chromosphere side of the transition to 1,000,000 degrees on the corona side of the transition. So this is a huge jump, and we don't really understand the reasons for this jump, although it's definitely a question on a lot of scientists' minds. Above the transition region is what we really expect to see during the solar eclipse. This is the corona, or the sun's crown. This is a spectacular region that's dominated by magnetic fields, and plasma is trapped on these magnetic fields, which gives it spectacular structure. The shape of the corona changes over periods of decades. So this period is called the solar cycle. The 2017 solar eclipse is going to be during solar minimum, so we expect the corona to look something like this during the 2017 solar eclipse. The corona is also where we see features such as coronal mass ejections begin to show. Although they originate close to the photosphere, the corona is really where we see them first because they're rapidly expanding. But we'll cover coronal mass ejections and solar flares in a later webcast. The outermost layer of the sun's atmosphere is called the heliosphere, and really this is stretching all the way out past Pluto. So we live in the bubble of the heliosphere, and we live in the atmosphere of the sun.